Welcome to Module 15, Fundamental Data Structure in Python. In this module, we'll discuss 4 data structures that Python offers, each playing a crucial role in the development of efficient and readable programs. In this first lecture, we'll begin our journey by learning about one of the most commonly used data structure in Python, that is the list. Lists are very useful when working with ordered collection of data. They are used in many real-world applications like data analysis, automation, web development, and even machine learning. Whether you are working with user input, storing records, and managing results from a program, lists are involved in some way. By the end of this lecture, you will understand what lists are in Python and how they are work in a program. Know why lists are important for organizing and working with data. Learn key features of lists like being ordered, mutable, and able to hold different data of Python. See how to create lists, whether empty or values, and how to add, change, or remove items. Practice useful list operations like indexing, slicing, and looping through items. Explore some helpful built-in functions that make working with lists easier and more efficient. Throughout this lecture, we'll provide practical demonstrations to help you clearly understand each concept and make the session more engaging. Now, what exactly is a list in Python? A list is an ordered collection of items. This means that the items are stored in a specific sequence and that sequence is maintained. Python lists are useful because they can hold a mix of different data types like numbers, strings, or even other lists. Lists are one of the most fundamental and flexible data structures in Python. You will find yourself using them often, whether you are processing data, storing results, or organizing items for further operations. Containers in Python. In Python, a container is simply a structure that groups multiple pieces of data into a single unit. We often refer to containers as collection or compound data types because they can hold many items together. Python offers us a variety of container types to work with, including lists, tuples, sets, and dictionaries. Each of these containers has its own unique properties and use cases, which we will explore further. Now, importance of list. Why are lists important? Lists are fundamental because they let us store and manage multiple items in a single variable. They offer flexibility. We can add, remove, search, or even sort items easily. Lists are widely used in Python programming for this flexibility. Let's look at some key properties of a list in Python. First, lists are ordered, meaning the elements maintain the same sequence in which they are added. Second, they are mutable, so we can modify, add, or remove elements even after the list is created. And third, lists are heterogeneous, which means they can hold items of different data types together like integers, strings, floats, and even other lists. Now, how to create list? We can create a list by enclosing elements inside square bracket. Here in this example, we have a list of fruits having 3 elements. We can also create an empty list using just empty square brackets. Here in this slide, an example of creating list is shown. Here we create a list called fruits containing 3 string elements: guava, grape and pineapple. Printing it always displays all the items. Similarly, an empty list is created using the square bracket. Empty list is initialized but has no items yet. Now let us discuss how to initialize list with some elements. In Python, a list can hold elements of different types, although usually we group similar items together. For example, the list name numbers contain only integers, while the list name mixed contains an integer, a string, a float, and even another list. For instance, the list student age contains 6 elements, which repeated values like 12 and 14. Thus, duplicate values are allowed in list. Additionally, we can use asterisk symbol to repeat an element multiple times. Here in this example, the list, namely value, stores the numbers 50 5 times, creating a list like this. Let us give a demonstration for creating and using list in Python. First, we create a list called fruits that contains 3 items: apple, banana and mango. When we print it, it displays all the fruits in the list. Next, we create an empty list named empty underscore list, and printing it shows just an empty pair of square brackets. We can also create a list of numbers. Here in this example, the list name is numbers, which holds values from 1 to 5. Printing it displays the numbers in order. List can also hold mixed data types too. For example, the list mixed contains an integer, a string, a float, and even another list inside it. Printing mixed shows all these different types together. List allow duplicate values as well. The list student underscore age contains some repeated ages like 12 and 14. When displayed, all the elements including the duplicates are appeared. Now, if we want to repeat a value multiple times, we can use the asterisk symbol. For example, value is a list where the number 10 is repeated 8 times. Printing the list value shows a list with 8 tens in it. Now if I save and compile the Python program, we can see the output like this. This is how lists are created and used in Python programming. Accessing list elements in Python. In Python, we can access elements in a list using their index. Python uses zero-based indexing, which means the first element of a list is at index 0. For example, my list of 0 returns the first element in the list. Python also supports negative indexing, which allows us to count from the end of the list. So my list of -1 gives us the last element and my list of -2 gives us the second to last element. This makes it easy to work with elements from both the beginning and the end of the list. Here in this slide, let us look at how to access elements in a list using indexing. We have a list called fruits that contains 3 items: apple, banana and guava. When we use fruit of 0, we get the first element, that is apple, because indexing starts at 0. Next, fruit of -1 accesses the last element, which is guava, using negative indexing. Similarly, fruits of 1 gives us the second element, that is banana. And fruits of -2 also gives banana because it's the second to last item in the list. This shows how positive and negative indexing can both be used to retrieve specific elements in a list. Now let us learn about nested list in Python. A nested list is simply a list that contains other lists as its elements. For example, we define a nested list called nested_list like this. Here first element is a list 1, 2, 3. Second element is also a list containing 4 and 5, and the third element is also a list containing 4 elements 6, 7, 8 and 9. Each element of this list is itself a list, also called a sublist. To access elements, we use multiple indices, one for the outer list and one for the inner list. Now, nested list of 0 refer to the first sublist, which is 1, 2, 3. Nested list of 1 and 1 accesses the second item in the second sublist, which is 5. Now, nested list of 2, 3 gives us the fourth item in the third sublist, which is 9. Using this approach, we can easily access and manipulate elements inside nested lists. Let us now discuss slicing elements in a list. Slicing allows us to extract a part of a list. Slicing is used to access a range of elements from a list. Here is the syntax: list name, then start and stop index within square bracket. In this example, we slice from index 1 up to 3, but not including index 3. So the output is banana and guava only. In this demonstration, we will look at how to access elements in a list, work with nested list, and use slicing to retrieve sublist. First, we define a list of fruits containing 3 elements: apple, banana and guava. We use indexing to access specific elements. First, if we try to print the fruit of 0, it will give us the first item, that is apple. Next, fruits of -1 accesses the last item, that is guava. Next, fruits of 1 returns banana, and using negative indexing, fruits of -2 also gives us banana. Now let us move on to the nested list. We define a 3 by 3 matrix as a list of lists. First element is a list containing 1, 2, 3. Second element is also a list containing 4, 5, 6. And third element is also a list containing 7, 8, 9. With a print statement, we are displaying the complete matrix. Then matrix of 0 accesses the first row, which is a list containing 3 elements 1, 2, 3. Now matrix of 1 and 1 gives us the middle element, which is 5. Then matrix of 2, 0 gives us the first element in the third row, which is 7. If I save and execute the program, we can see the output of the matrix. Here is the output for accessing list elements. Finally, let us look at slicing, which lets us extract a portion of a list. We redefine the fruit list to include an element, date, as well. Fruits of 1 is to 3 returns items from index 1 up to but not including index 3. It returns banana, guava only. Fruits of colon 2 slices from the start up to index 2, giving us apple and banana. Next, fruits of 2 colon gives us everything from index 2 to the end. The output will be guava and date. These are the basics of accessing and slicing list elements in Python, including how to work with nested list. If I save and execute the program, we will see this output. Fruits of colon 2 will give apple and banana, and fruits of 2 colon will give guava and date. Now, how to modify a list? We can use different list methods to modify a list. Lists in Python are highly flexible and can be modified in several ways. Let us go over some of the most commonly used list methods. First, append method. The append method adds an item to the end of the list. The insert method allows us to add an item at a specific index, and it is very useful when order matters. Next, the remove method. To remove an item, we use remove method. It deletes the first occurrence of the specified value. Next, the pop method. The pop method removes and returns an item. If no index is specified, it removes the last item by default. When we need to sort our list in ascending order, we can use the sort method. The reverse method flips the list order completely. These methods are fundamental for effective list manipulation in Python. Now let us take a look at 3 other useful list methods in Python, which are count, index, and clear. First, the count method. Count method tells us how many times a specific value appears in a list. For example, if we have a list called mylist and we call mylist.count to, it will return how many times the number 2 occurs in that list. Next, we have the index method. Index method returns the position of the first occurrence of a specified value. So, mylist.index1 will give us the index where 1 appears for the first time. If the item is not found, Python will return a value error. Finally, the clear method. This method removes all items from the list, leaving it completely empty. Calling mylist.clear is a quick way to reset the list and start fresh. These methods are simple but powerful tools for analyzing, accessing, and managing list data effectively. Let's explore a few basic list methods in Python with some examples in this demonstration. We begin with a list named list1 containing the elements rows, lotus, lily, and tulip. There are 4 elements in the list 1. First, we print the list to see its initial content. Next, we use the append method to add a new item orchid to the end of the list. After appending, we print the updated list. It will display total 5 elements including the new element orchid. If I save and execute the program, we will see the output. Now we use the insert method to add sunflower at the index 2. This shifts the existing elements to the right and places the name sunflower at the 3rd position. We will print the list again to confirm the changes. Finally, we use the remove method to delete the item rows from the list. This removes the first occurrence of rows, and we print the list 1 last time to view the final result. These simple list methods, append, insert, and remove, help us to manage the contents of a list effectively. Let us consider another list called MyList, containing the elements 4, 5, 2, 7, 8, 1, and 10. We print the list to confirm its content. Now we use the pop method. First we call mylist.pop4, and this removes the item at index 4, which is 8. We print the list again, and 8 is removed. Next we call mylist.pop with no arguments. This removes the last item in the list, which is 10. We print the updated list once more, and after saving the file, we execute the program. And here is the output. First 8 is removed, then 10 is popped. Now let's sort the list in ascending order using mylist.sort. The list is rearranged from the smallest to largest, that is in ascending order. To sort it in descending order, we use mylist.sort within parentheses reverse equal to true. The list will be sorted from largest to smallest, that is in descending order. I am executing the program, and here is the output. List is sorted in ascending and descending order. Next, the reverse method. Calling mylist.reverse simply reverses the current order of the list. It does not sort, it just flips the list as is. Now let us explore a few more list methods: count, index, and clear. We define a new list called numbers with the elements 4, 2, 8, 6, 2, 5, 9, and 3. Calling number.count2 returns 2, meaning the number 2 appears twice in the list. Using numbers.index6 gives us 3, which is the index of the first occurrence of the number 6. Numbers.clear removes all items from the list, leaving us with an empty list. We print the list one last time to confirm, and it is empty. I am again saving and executing the program. Here are the outputs of the program. At the end, the list is empty. These list methods are powerful tools for managing and manipulating data in Python. Now let us discuss the built-in functions for list in Python. In addition to list methods, Python provides several built-in functions that allow us to perform common operations on list efficiently. The len function returns the number of elements in the list. For example, if a list contains 3 elements 1, 2, 3, then the len function will return 3. Next, the max function. Max function is used to find the largest item in the list. For a list containing 3 elements 1, 2, 3, the max function will return 3. The min function returns the smallest item in the list. The sum function is used to get the sum of all items in the list. For instance, sum of 1, 2, 3, it will give the total of the 3 elements, that is 6. The sorted function. Sorted function returns a new list sorted in ascending order without modifying the original list. Any function returns true if any element in the list is true. For instance, any, then the list elements are 0, 1, 2, returns true. Again, any and the elements are 0, 0, 0, returns false because not a single element is true. Next is all function. All function returns true if all elements in the list are true. For example, all is applied to a list containing 1, 2, 3 returns true, but all 1, 2, 0 returns false because of the element 0. Let us look at how Python's built-in functions work with list using this example. We start with a list of numbers containing 12, 6, 5, 2 and 0. First we print the list to see its content. It will display the list. Using len numbers, we find the length of the list. In this print statement, len function is called and it will return 5 because there are 5 elements in the list. To find the largest number in the list, we will call the max function, which gives us the largest value in the list, which is 12 in our example. The min function returns the smallest value, which is 0 in our list. Next, we will call the sum function, which will add up all the values in the list. The output will be 25 for our list. If we call the sorted function, it will return a new list with the numbers in ascending order. The any function checks if any value in the list is considered true. Since only 0 is false and all others are non-zero, it returns true. On the other hand, the all function checks if every value is true. Because 0 is in the list, this returns false. If 0 is not present in the list, it will return true. If I save and execute the program, we'll get the output as follows. These built-in functions are fast, simple, and useful for working with lists in Python. Here are the outputs of the program. The length, maximum, minimum, sum, sorted, any and all. As we have discussed all the important concept of Python list, let us now assess your understanding with a few multiple choice questions. Here is the first question. What is the output of the following Python code? Options are given here. The correct answer is option C, 4, 5. Next question. Which built-in function returns the number of elements in a list? Here are the options. The correct answer is option D, the len function. Next question. How do you create an empty list in Python? Options are given here. The correct answer is option C, empty equal to empty square bracket. The last question. Which property of Python list allows elements to be changed after creation? Here are the options. The correct answer is option B, mutable. Let's now quickly recap what we have learned in this lecture. We started by understanding what a list is, an ordered collection of elements that can store data of different data types in a single variable. We discussed why lists are so important in programming, They help manage data efficiently and are commonly used in loops, functions, and all kinds of data processing tasks. We explored the key characteristics of lists. They are ordered, mutable, and heterogeneous. Then we learn how to create an initialized list from empty ones to those with numbers, strings, or even other lists. We saw how to access elements using indexing and how to use slicing to extract portion of a list. We also looked at some commonly used methods like remove, sort, reverse, and more, which help in managing and transforming lists with ease. Finally, we explored useful built-in functions such as length, sum, max, and sorted that enhance how we work with lists. Thank you for joining the session.